Hey guys, it's your host Subhra. Welcome to your favorite channel, Subhra the Geek. So today we are back with our second video in our statistics series. So today we'll be learning about how to use plots for visualizing the data and what are the needs of plots, what are the different kinds of plots, and this will be explained by my very good friend Debayan. Along with him, I have designed few series for you guys to understand, to get yourself inside the journey of machine learning and quantum computing. Guys, if you face any problem during your journey, we have made an exclusive Discord server which is linked down below. You can ping us at any time and we'll be there to help you throughout your journey. If you have any suggestions, do comment in the Discord. If you like the videos, please hit the like button and please do share it with your friends whom you think you will benefit from this kind of videos. And guys, uh, please hit the subscribe button to get notified each and every time we give an update to our series and we post a new video. So guys, without further ado, I am your host Shubro. Along with me is,
Debayan.
let's start, shall we? So the one today we are gonna talk about plots, am I right?
Yeah.
So let me give them a brief idea about what are plots and then you can begin.
Sure.
So guys, we often at times find a huge number of data and we want to visualize that data. So how can we do that? We can do that by plotting that data on a graph. So what is a plot? A plot is nothing but a graphical technique for representing a huge amount of data, usually as a graph showing the relationship between two or more variables. The plot can be drawn by hand or by a computer. So we visualize a huge amount of data inside a small sheet to understand the trends, to understand various things about the data by visually seeing what is there and what is the relationship among the data. So my very good friend Debayan will come next and explain you different types of plots and what are the use cases of them. So without wasting any of your time, let's give it to Debayan. So Debayan, next will be you. Okay.
Yeah. So we're gonna start out with the basic plots and statistics, and I'm gonna talk you through the details and when and how we use them.
So Deban, let's begin with scatter plots. So give them an example and briefly describe them. What is scatter plots?
Yeah. So a scatter plot is exactly what they sound like. It's in the namesake. So when you're talking about scatter plots, you're talking about just plotting the data as it is, and just seeing how the scatter looks like, right? How the chaos looks like in the data, and see if there's some pattern in it. Generally, when you're talking about scatter plots, you're talking about two variables. Let's say variable A and variable B. You're talking about that some variable A affects some variable B, right? And you want to understand the relationship between A and B. In this case, A is your explanatory variable. This is A explains B in some manner which you do not know, you want to find out. And B is the response variable or the target variable which you want to understand how it is affected by A. Now the explanatory variable, right? Let me write it. Explanatory variable, and then the response variable, right? So the explanatory variable A always goes in the x-axis, right? And the response variable Y or B over here always goes in the y-axis. We have two sample plots here. Let's try to understand them, using the sample plots that we have here. So this is the y-axis.
Deban, could you
This is
zoom in a bit?
yeah, so that you can see very clearly. Yeah, so this is the y-axis, this is the x-axis. You will put your explanatory variable over here. You will put your response variable over here, and you're gonna see how the the chaos in the data looks like. You're just gonna plot just numbers over there. Point to note: A and B must be numerical variables. You cannot have categorical variables over here. Categorical variables will have different treatment. If you do not know what categorical variables are, please refer to our previous video where we have explained that in more detail. So in this plot, as you can see, it's pretty chaotic, right? It's like there seems to be some concentration of like points over here, but it's still not dense. It's still not like clustered around certain point. It has a tendency, but it's not still not clustered around. This is what you would call less scatter, right? It's not dense enough, so it's less scatter. The second plot has a very nice pattern to it. Can you see this, right? So you have A over here, right? A is over here, and some B is over here, right? You can almost plot a line that goes through right by it, right? It seems as if it's a linear scatter, right? This is what you'd call less scatter. Like it's literally in the name, it's less. The chaos is less, right? There's a
Devan,
pattern.
I
There's a
think the previous one would be high scatter.
Oh, sorry. Yeah, it's
Yeah,
high scatter.
actually.
Yeah, sorry about that. Happens. Yeah, so this is called what you call high scatter. It's called less scatter, and there's a trend along with it. It is almost like linear. There's a linear relationship, it seems. So as A increases, B also increases in some manner. Over here you can't see a noticeable pattern over here. So if A increases, is there an increase in B? You really can't say about that, right? So in the second case, you would say that if B increases with A, right, you say this is a positive direction. This is a positive direction, it's a positive scatter. Over here it's nothing much, you can't say too much about it. But if there was a plot, and the plot looked like exactly opposite of what you see on the left hand side, so it should look like something like this, right? If you had a plot like this, then this is what you would call a negative direction, right? A negative slope. This is a negative slope, this is what is called a positive slope, right? So what does the amount of chaos means, right? So if you have high scatter, it means that there is a weak correlation between A and B. There's a weak correlation between uh you know your explanatory variable and your target variable. If your scatter is less, like you see in either one of these cases, it can either be positive, it can either be negative. If the scatter is less, right, it's less spread out across the plot, then it's a high correlation between A and B.
So, Deban, let's now introduce what is histogram, and let's talk a bit about histograms.
Yep, sure. So in histograms, what you do is you take a single variable, you work with a single variable, and histograms are used to understand the distribution of a single variable, right? So a single variable V, so distribution, that's all what a histogram does, right? So in the x-axis, this is a sample histogram. In the x-axis you have intervals, right? So this variable v can have has many values. It's a numerical, it has to be a numerical variable, otherwise you don't have a histogram for categorical variables. So you can have a minimum, right? So this is your mean and this is your max, right? Let's say this is 0 and this is, let's say, 100, right? So what you would have over here, you would have distribution, you have ranges. So there are 1 2, so 1 2 3 4 5 6 7 8 9 10. There are 10 bars over here. So what you would have, so everyone would have range from 0 to 10. This would have from 10 to 20. This would have from 20 to 30, and so on and so forth. Over here 90 to 100. This is how the x-axis is distributed for or made up for a histogram. On the y-axis over here you have frequency, right? So what do you mean by frequency in a numerical variable? So if v, right, if v is an array or a list of numbers that looks like this, sorry, so it's like 8 over here, there's like 15 over here, there's like 7 over here, right? If it was a variable like this, then what you would have is 0 to 10. How many variables are between 0 and 10? How many variables are in that range? You would have 9, 10, 8, and 7. So over here this would be 4, or someone along like here, it will be along here in this case, right? And if it is 15 and 20 that comes in the next phase, then you would have 2 over here. So someone along here, just like it's 2 over here. So this is how you do, you find out how many variables lie in those ranges that you have defined in the x-axis, and then you count how many values in the actual data there is that comes under over there. This almost forms a shape that you will be you will be knowing in the in the upcoming lectures, which is it looks like a normal distribution. If you look at this curve, right? If you look at this curve, it almost looks like a single curve, like it's a single bell curve to be precise. This is what is called a normal distribution, and we're going to talk about this more in detail in the upcoming videos. So what does the histogram do? What does the histogram tell you about a single variable? Right? It tells you, it gives you an idea of the data density. How densely packed is the data? Right? So if you have more frequency for a specific range over here, so the bar will be very high. If you have less frequency in certain ranges, the bar will be very low, right? And it will sort of give you a sense of how densely packed the data is across the various ranges, and it will give you a shape to identify with that. You can have various types of distributions based on how you categorize them, right? So on the top hand side, you will see, based on how the shape tilts to the left and right, you can have three basic shapes. So this is the normal distribution, very close to the normal distribution, the ideal one. And it's called symmetric because if you break this up, it's equal on both sides, left and right. And it's also called unimodal. We're going to talk about that just after I explain this. So a symmetric one is equally distributed on left hand side in terms of density. You have a skewness, you have something called a skew left, right? So what do we mean by that? So distributions can either be skewed to the left or the right, and they are skewed to the longer side of the tail. So this is what you'd call the tail. This is what you would call the tail, right? So it's distributed over here. So if the emptiness is over here on the left hand side, you call this skew left, and on the right hand side the tail is on this side and the emptiness is rise on this side, so it's what is called skew right. It's still a distribution, it's still a histogram. You can see the individual boxes over here plotted. It's still a histogram, but based on how it's tilted towards the left and right, you can call it a skew left, a skew right. How does this matter? We're going to talk about that and how it impacts, what kind of meanings it has in the upcoming lectures. There's also a second category, a second way you can work with histograms. You have something called modes. Now what are modes? Obviously we're going to talk about that as a statistical measure, but it's basically the number of peaks that you have. Just for the sake of this lecture, let's understand them as a measure of peaks, or number of peaks that you see in the distribution. So over here, this is also a histogram, but there are no peaks, right? So there are 0 peaks. Over here there are 2 peaks. So this is one peak 1, so this is peak 2. Over there is many peaks. It can have more than like 2 peaks, right? It can have 3, 4, 5, as many as you want. So this is peak 1, peak 2, peak 3. There are 3 peaks over here. So this is what you would call multimodal peak. Do you know what's a unimodal peak over here? It's this one, the symmetric one. There is only one peak over here, and it's called unimodal. And based on this number of peaks that you have in a histogram, you can call it the modality of the histogram. So the number of peaks is equal to the modality of the histogram.
So Debayan, let's talk about something we know as box plots. So
Yeah.
those are very important while analyzing different kinds of data. So let's talk about this.
Yeah. So a box plot is a very unique kind of plot, and it is useful for highlighting outliers, or the median of the data, or the interquartile range of the data. Now what do I mean by those things? We're going to obviously talk about median and IQR in more detail in the upcoming lectures, but just for the sake of understanding over here, what are outliers? Outliers are basically the abnormal data, right? So a data that lies, it seems abnormal and lies beyond the data distribution. So over here, this is what a typical box plot looks like. And when you plot a data, it's always a numerical data. Please consider that in mind. It's always a numerical data, and we plot on a box plot of a numerical data. This is how the plot should look like, more or less, right? So this is the minimum. This is the mean. This is the max, right? So this is about 1.5, the IQR. This is the median. The mean will almost be around over here, and then this is the 75 percentile and 1.5 IQR. What this means, we're going to talk about that detail in more in the upcoming videos. But just know that for now, these things that come over here, right? These things that come over here, these are outliers, and these are very rare in cases. They're not supposed to be there. At certain cases, when you observe the data, you see these points. These are what you'd call, these are abnormalities. This is where the abnormality of data comes in, and you need to understand and treat how this comes to being and how you work with this. To be clear, box plots do not display any kind of modality like we discussed with histograms. They do not display skewness. They do not display things like that from here. Uh, so so mean, max, interquartile range, median. That's all the information we can get for a box plot.
Deban, so in box plots also we like this is mainly what I can suggest a use case of this is fraudulent detection of credit card frauds is a very good example which we used to learn.
So all the normal distributions are like you and I do, right? I would expect all the normal, Paytm distributions or PayPal distributions that or transactions that you do always come along this range. Let me highlight that. It will obviously come around this range, right? With
Mm-hmm.
the density being the highest over here. Let me change the color. So the density is always high in the middle over here, right? And as it goes along, it becomes more and more rare in this case, either way. Now, the data that you see on the left hand side, on over here and over here, it's highly likely to be fraudulent due to some reason. Maybe you're trying to pay from a various from using a VPN or something, and you're trying to use some kind of maybe the dark internet. You're trying to go on the dark web and pay something. That's where the fraudulent transactions come into play, and these are very rare scenarios. That's why you can mark it as outliers in your data.
And we will be talking about them a lot when we'll be discussing about different kinds of data and datasets in our upcoming series.
Mm-hmm.
So, Deban, let's now talk about something we call as segmented bar plots.
Segmented bar plots is a is a very special kind of exotic plot. To be honest, if you want to talk about more
Exotic.
understand more about bar plots, right? You can go to back to our previous video where we talked when we briefly explained what a bar plot is. Over here, what a segmented bar plots are, they are specifically meant for categorical variables. Let me write that down. It's meant for categorical variables only. You might ask, what's the difference between a histogram and a segmented bar plot or a bar plot in general? A segmented bar plots, right, or bar plots are mainly used for categorical variables, and histograms are mainly used for numerical
Numerical
variables.
variables.
Segmented bar plots are useful for visualizing conditional frequency distributions for the categorical variable. So every type can have three. So these are the categories. These are the factors. These are the levels. What you call, right? These are the factors at the levels. And segmented bar plots are useful for visualizing the conditional frequency distributions of each of these categorical variables A, B, A to E. Right? The distributions of each level, this is a level, the distributions of each level, you call the factor, category, or class in a categorical variable A, B, C, D, or E. It's said to be conditioned onto the levels of another variable. You can generally have two variables over here. So this category is maybe another variable, so B. So it's not, sorry, it's not B, it's another variable called maybe y, and these are all x variables. So this is an x categorically x class of variables, and these are y class of variables, and you're trying to understand the relationship between two categorical variables and how x influences y. Remember, in the first time in the scatter plots we're talking about x and y. They also try to understand a relationship, but those are numerical variables. Over here, it's both of them are categorical variables, and you're trying to understand how one category of one exploratory variable x, it tries to understand the category of another response variable y. That's what all segmented bar plots does. You can use it to compare the relative frequencies, the relative frequency like this one, this and this, along with for every separate explanatory variable, and try to understand if there is a relationship between the distributions over here.
So, Deban, let's talk about something we know as radial plots. So it's useful in different times. So please explain how radial plots are drawn and how we can use them.
So radial plots are, at times confused based on how if you do not know how to interpret them, how to draw them. So radial plots are a graphical way to display multivariate data, but in a 2D form. You might also say, hear people call them web charts, spider charts, polar charts, right? So how do you go around them with them? How do you work with them, right? So consider a data set, a very typical looking data set, and which has two observations. That means two rows or two examples, right? and let's work with 6 columns or 6 variables to consider. Right, let me draw a visualization of the data set and how it might look like. Let me draw 6 columns. So 1, 2, 3, 4, 5, 6. So let me number them. So you have 6 columns over here. Let's draw 2 rows worth of observations. We're gonna call this example 1 and example 2. So 2 rows worth of observations, and you have values in each of these cells individually, right? So how do you go about it? You're gonna so based on the number of columns that you have, or the number of aspects or dimensions, that those are the vocab in a radial chart. So the number of dimensions that you have, the number of columns that you have, you're gonna draw over here. It's sixth vertex. You're gonna draw 6 vertex, a polygon to denote 6 aspects to consider, right? And the way it works is that you're going to take each example and you're going to plot it along those 6 aspects, right? So over here we have an example. So let's consider them v1, v2, v3, v4, v5, v6, right? And the lines are distributed in a various scale. So let's consider, so this is 0, this is 10, 20, 30, 40, 50. You can have a different scale based on the number of values that you have. What you're gonna do is you're gonna take the first row, you're gonna take e1's worth of values for each of those columns, and then you're gonna plot them in each of the axes. So e1 v1, right? So e1 v1 will be over here. E2, so e1 v2 will be over here. So this is e1 v3. This one over here is e1 v4. This one over here is e1 v5, and this one over here is e1
E1
v6.
V6, yeah.
Yeah, and you're gonna do the same for all the rows that you have in your data set. So we have e2 over here. So we're gonna do this one will be e2 v1. Same over here, e2 v2, and
2.
so on and so forth. So what you're gonna get is it's gonna look something like this. What it tells you, what it tells you, which aspects of the rows, of all the rows that you have plotted, are very strong, right? It almost gives you a personality kind of aspect. That's why you see this in various personality kind of depictions of plots. Not that they are completely right, in my opinion, but they sort of help you understand which aspect of the standardized character side, side, like consciousness, agreeableness, and those kind of aspects or dimensions or columns in this case, do you more aligned to, more stronger in your aspect. That's what it tells you. And when you do this for many rows, many examples, you can see a common pattern, that one aspect or a couple of aspects of every row of that data set is highly strong on one aspect or couple of aspects, and very weak, like you see in certain examples, like this aspect, it's very low in certain aspects and very high and in certain aspects. That's what it's telling you, which aspects or which dimensions, so-called columns, are strong and weak for your entirety of your data set.
So, Debayan, today we learned about how to use plots to visualize data, what are the different kinds of plots, and
Mhm.
we'll be talking a lot about them in our later upcoming videos. So, do you have any suggestions for them?
I would really recommend that you start, exploring your data in a better way using plots. These are what you would call windows into what the data holds might hold for you, and it is very important that you use them in your exploratory data analysis or EDA. These are what you would call the cornerstone of ADA, and you have to use them in some aspects. So I recommend you that you become very familiar with Matplotlib, Plotly, or even in R. So you have ggplot, the whole ggplot convention framework. So I would ask you to really get familiar with them and how to use them in various aspects based on your data.
So, guys, it was all from Debayan's end for today. Guys, thank you for staying with us for so long. So today we learned a lot about plots and Debayan's suggestions also, which we should implement in ourselves, so that we can have like the industry insights he gave to understand exactly what we need to study, not the whole thing, but the things which we need to study. So, guys, without wasting your time, we have our Discord server ready, which is linked down below. We are there to help you out throughout your journey. I and Debayan will always be there. If you find our videos likable, if you like our videos, please give a thumbs up. Please subscribe to our channel. Please hit the bell notification icon beside it so that you get notified each and every time we post an update. And guys, that's all for today. I was your host Subhra. Along with me was
Debayan.
signing off. Bye bye.